Section 3.4, Linear Programming. Example 1. Miss Gilmore is planning on opening a bakery and plans to bake cakes and specialty pies. She estimates that a cake will take 75 minutes to prepare and a specialty pie will take 30 minutes. Miss Gilmore plans to work no more than 40 hours per week and does not want to make more than 60 pies in 1 week. If she plans to charge $34 for a cake and $16 for a pie, find a combination of cakes and pies that will maximize her income for a week. So these are maximum profit equations that we're doing, and the way that we do them is we have all these steps that we're going to go through, and our graph is going to help us determine what the maximum income for a week can be. So before we do that, we always want to define step 1, our variables. So what two things are we talking about? And normally you can look at what two things we in the question. So it says find a combination of cakes and pies that will maximize her income for a week. So cakes and pies are the two things that we are discussing. So I'm going to say let x equal the number of pies and y equal the number of cakes. Now, if you were to switch that around and say x was a number of cakes and y was a number of pies, that would be okay. The whole point is that we're writing down what our x and our y stand for. So because we have it written down, we don't need to worry about which variable stands for what. So now that I have this, I need to actually come up with my equations. And I could have multiple equations. I could have 2 equations, I could have 3, and so on. So for this, we have to think about what two things we're talking about. So it says we're talking about hours per week and how many pies we're making. So let's take a look at the minutes and hours first. So it takes 75 minutes to prepare a cake, and a specialty pie will take 30 minutes, and it says that she plans to work no more than 40 hours per week. So that's the first thing I want to come up with an equation for. So for my first equation, we have x is pi, so I'm going to start with that. So 30 minutes for a pie, so 30 times x plus the amount of time it takes to make a cake, which is 75 minutes. So 75 times y, and it says that Miss Gilmore plans to work no more than 40 hours per week. So this is going to be less than or equal to, and we can't put 40 there since we're talking about 75 minutes and 30 minutes. I have to change 40 hours into minutes. So how do I do that? I'm going to do that off to the side over here. So 40 times, and then how many minutes are in an hour? 60. And so we get 2,400 minutes. So that's what goes right here. Then another equation that I'm talking about, it says she does not want to make more than 60 pies in 1 week. So if x stands for the number of pies and y stands for the number of cakes, I would simply add those two together. So x amount of pies plus y amount of cakes. We know that, again, she does not want to make more than, oh no, I'm sorry, I read that wrong. So if it says that she does not want to make more than 60 pies in 1 week, so x is the only thing that stands for pies, so then x would have to be less than or equal to 60, and that would be our second equation. Now, 2 more equations that we don't always write down, but I'm going to talk about them for this first problem, is that we know, can we have negative pies? No. So since we can't have negative pies, we would also include that x has to be greater than or equal to 0, and we also can't have negative cakes, so y would also have to be greater than or equal to 0. Now, we don't always write those 2 last equations down. However, for this being the first time that we're looking at these, I'm going to write them so that you can see it. After we do step 2, writing the system of inequalities, which are called your constraints, you want to graph them. So in order to graph these equations, for the first one, I'm going to have to take that equation and solve it for y so that I have y equals, so 30x plus 75y is less than or equal to 2,400. And then I'm going to subtract the 30x. And then I get 75y, this cancels out, is less than or equal to negative 30x plus 2400. And then I'm going to divide everything by 75. And when I do that, I end up with, and I'm going to run out of room here, so I'm going to write it over here. Y is less than or equal to negative 2/5 x plus 32. So this is right here, that first equation that we came to solve for y. Okay, so the next part, it says find the coordinates of the feasible region for step 4, but before we can do that, we have to graph these. So let's talk about graphing them. So on my graph, we already defined our variables, so I'm going to write that down on my x and y axes here. So x is the number of pies, and you always want to make sure that you labeled, because that's going to be worth 5 points on your next quiz. And then y stands for the number of cakes, so I'm going to write that over here. That's easy points. Now that I have that written, I need to figure out what my x-axis and my y-axis is going to go by. So if I look at my highest y value, I know I have 32 for y-intercept, so that means I'm going to want to go up to 32 on my y-axis. So I'm probably not going to go by 1s, maybe 2s might be better. I could even do 5s if I wanted to, but 2 sounds like a better number since I'm going up to 32. So 2. 2, 4, 6, 8, 10. So 32 would be the next one above that. Okay, so now I know I can put right here on my graph my y-intercept for this graph, which is 32. Now, notice the slope is negative, so normally when I have a negative slope, I'm going to think about finding my x-intercept. It helps me to graph it. So I'm going to do that. I'm going to find the x-intercept here. So how do you find the x-intercept? You plug 0 in for y and solve. So subtract the 32 the other side, you get negative 32 is less than or equal to negative 2/5 x. So here you can divide both sides by negative 2/5 and then in your calculator figure out what it's equal to, or you can multiply both sides by negative 5/2. It'll give you the same answer. And when I do that, notice I'm multiplying or dividing both sides by a negative number, so I have to flip my inequality when I'm solving. So I know that it doesn't really matter in this case because I'm just going to look for the number I'm going to put on my x-axis. So in this case, I end up with 80 is greater than or equal to x. Now, like I said, we don't really need that inequality there. We're just trying to figure out where to go on my x-axis. So for this, if I'm all the way at 80 for an x-intercept, that means that I'm probably not going to want to go by 2s. Maybe 5s would be a little bit better. So we're going to go by 5s. So this would be 5, 10, 15, 20, 30, 40, and that would be 80 right there. So then I'm going to put my x-intercept there, and I'm going to then graph my line with my ruler. And notice that I'm not putting arrows on the ends of my graph here because we're not going to have negative pies and negative cakes, so my graph is going to stop there. Okay, so I'm going to erase this right here so I have room to write. So now I have my first line graph. Now I also need to graph x is less than or equal to 60. So remember, if x equals some number, you have a vertical line that goes through your x-axis. So in this case, I have a vertical line at 60. So I'm going to get my ruler again and make a line going this way. And I could put an arrow at the end going up for that one. And then the other thing that we know is that we have to be above 0 for the number of pies, and we can't above 0 for the number of cakes. So I can also make lines right here. Oops. Let's delete that one. Let's try that again. Okay, so starting here. So this would be my x-axis, and I have to be above that line. And my y, like I said, we don't normally draw those in, but I'm doing it this for the first time so that you can see. And now that I have that, I'm not finished, because remember, whenever you're graphing inequalities, you have to graph the shaded region. So what I like to do, because you're going to be graphing a lot of lines, I like to label my lines so that I know what they are and I don't forget. So this is x is less than or equal to 60. If we want numbers that are less than or equal to 60, that would be shaded to the left. And then for my next line that I have here, which I'm going to label as well, this was y is less than or equal to -2/5 x plus 32. Now for this one, since it's y is less than or equal to, that means I'm going to shade below. The line. And then for my last two, I had x was greater than or equal to 0 and y is greater than or equal to 0. So this would be x greater than or equal to 0, which means shade right. And this one down here is y is greater than or equal to 0, which means shade above, since it's y is greater than. So shade above. So now if I think about this, where my shading is going to be, I am going to get my marker here. So we're shading to this way for this equation. And for this line, we're shading below the line going this way. This one, we're shading this way and this way. So what you need to do is look for the area in which the shading is going to be for all of the lines. So that's going to make this area that we have right in here. So let me get my highlighter and I will highlight that. So you can do this with your highlighter. I find it's nice to use the highlighter again, because if you make a mistake, it's easy to go over in pencil or some other color. So this right here is what's called your feasible region. Whoops, I didn't mean to go out there a little bit with the lines. Because this is the region that satisfies all of my inequality restraints. And of course, we wouldn't have gone over there. Now, with this, it says find the coordinates of the feasible regions. Now, after I've graphed my equation, the coordinates of your feasible region are going to be the coordinates where your shading ends. So one's right here, right here, right here, and right here. That's why it's really important when you're graphing these that you make sure that you are graphing them as accurate as you possibly can, because we have to figure out what those points are. Now that I have them, I'm going to write the coordinates down so that I know what they are. So in this case, the coordinates of the feasible region, we'd start right here with this one, which is 0, 0. The next one I had was 0, 32, and I know that because it was this y-intercept here. The next coordinate that I have is right here in my graph, so if I didn't graph my lines very well, then I wouldn't know. I know it's 60, and then if I look right here, I know 2, 4, 6, 8, so 60, comma 8. And if you didn't know that, what could you do? Since we learned about how to solve systems of equations, you could do substitution to figure out what that was equal to, using those two lines that we have. And then the last one down here, which is this point, we have 60, comma 0. So step 4 is done. Now we're going to do step 5. It says write the function to be maximized or minimized, which is called your profit function. So your profit function is most often the part of our example that was asking the question where it says when her or his maximum income is going to be, or minimizing the income. So I'm going to highlight in my word problem so that you guys can see. So it says if she plans to charge $34 for a cake and $16 for a pie, find the combination of cakes and pies that will maximize her income for a week. So that is going to be my profit, help me write my profit function. So for this, oops, you'll just have to look at your paper to help write it. We know that our profit function is going to be P, and we have two variables of X comma Y. So the profit is going to be equal to, well, X stands for pies, and it's $16 for a pie, so 16 times X, plus Y stands for cakes, so it's $34 for a cake. So this right here would be my profit function, which would tell me how much money that I'm making given how many cakes or pies that I am baking. So the next one, step 6, it says substitute the vertices into the function. So what we're going to do is make ourselves a table here. Use my ruler to help me do that. So you should also make a table. And since we have 4 vertices, I'm going to make 5 lines. Okay, so in the first set, we're going to put the X and Y coordinates that we found for our feasible region. So that was 0, 0. Then we had 0, 32, and 68, and then 60, 0. And then in the next piece, we're going to do our profit function. So P of X comma Y equals 16X plus 34Y. So now I'm going to just plug in those X and Y coordinates that I have. So in this case, I have 16 times 0 plus 34 times 0. And then I'm going to write the total in the next column, so I'm just going to hold off to that. So this one would be 16 times 0 plus 34 times 32. 16 times 60 plus 34 times 8, and 16 times 60 plus 34 times 0. And in the last column, we're going to do the table, or total table, sorry, total amount of money. So 16 times 0 plus 34 times 0 gives me $0. So obviously that's not going to maximize my function to use the 0, 0. If I do 16 times 0 and 34 times 32, I get $1,088. The next one's going to give me a total of $1,232, and the last one's going to give me a maximum profit of $960. So then the next thing that I would do is I would take my highlighter or circle or whatever you want to do. Usually highlighter is the easiest. And I'm going to highlight my answer. That gives me the maximum profit, which means the most for my money, which would be this one right here. And then step 7 says we want to answer the question. So let's go back up and see what the question was. It says, if she plans to charge $34 for a cake and $16 for a pie, find a combination of cakes and pies that will maximize her income for the week. So we just found that, which was 60,8, which gave me $1,232. Which would be the maximum. So for this, that means, remember, X stands for the number of pies, Y stands for the number of cakes. So now we just need to answer the question, and of course, we're going to answer it in sentence form. So she needs, or I should say Miss Gilmore needs, so let's do Miss Gilmore. Miss Gilmore needs to bake 60 pies and 34, or sorry, or no, 8, not 34, and 8 cakes to maximize her profit. And this right here is actually the answer to the entire question, but in order to get to this answer, we had to go through all of these steps. So just to recap again, the first thing I had to do was define step 1, define my variables. After I do that, figure out what your equations are. After you do that, then you're going to graph them. And don't forget, since we're going to be working with inequalities, you'll have to shade it. And this gives you your feasible region. So the feasible region, again, are the coordinates where your lines are intersecting with the shading. Then write down those coordinates. Figure out your profit function by looking at what you're going to maximize or minimize. And then write it in a table. And yes, I want you to write a table. And then the last part is going to be answer the question. So the problem that is on the back side of this sheet, we will do that tomorrow in class, but make sure that you have everything written down here so that we have it for class to do.